Good day and welcome back to the Johnson Space Center in Houston. You're inside the International Space Station Flight Control Room, where at this hour a shift handover has been completed. The Orbit 1 team that had been on console throughout the course of the overnight hours and which supervised the grapple and capture of the Japanese H-2 transfer vehicle, the HTV-4, that occurred at 6:22 a.m. Central Time this morning, has yielded to the Orbit 2 team of flight controllers, the new team on console to supervise the installation and final bolting of the HTV-4 onto the Earth-facing port of the Harmony module, and a stay of a month to deliver more than 3.5 tons of cargo. On console at this hour here in the flight control room, Flight Director Judd Freeling on the right side of your screen is on console, joined by spacecraft communicator Takuya Onishi of the Japan Aerospace Exploration Agency, which is fitting today since it was JAXA, as it is called by its acronym, that built and delivered the HTV-4 to orbit with its launch 6 days ago from the Tanegashima Space Center in southern Japan. You're looking now at the flight control room in Tsukuba, Japan, where the flight control team is monitoring the HTV systems as it is being prepared for its installation onto the Harmony module to become a permanent fixture of the International Space Station for the next month. Since we left you after the grapple and capture of the spacecraft that occurred at 6:22 a.m. Central Time this morning, as the HTV and the International Space Station flew 260 statute miles just to the south of South Africa, the crew on board the International Space Station that oversaw the actual capture of the spacecraft, NASA flight engineer Karen Nyberg, assisted by flight engineer Chris Cassidy of NASA and Luca Parmitano of the European Space Agency. They have yielded control of the Canadarm2, the station's robotic arm, to the robotics controller here in Mission Control at the console called Robo. You're looking over the shoulder of the robotics officer John Bellingham, who has been sending commands to maneuver the station's robotic arm first to an inspection point that was just completed, where Chris Cassidy used his digital cameras and television cameras on the space station to do an inspection of what is called the PCBM. That's the acronym for the Passive Common Berthing Mechanism, essentially the latching mechanism, the docking mechanism on the side of the HTV-4 spacecraft itself that will be mated to an active common berthing mechanism on the Earth-facing side of Harmony a short time from now to complete the formal installation of the spacecraft. With that PCBM inspection now complete, the robotics officer, again, John Bellingham here in Mission Control, will maneuver the HTV-4 into what is called a pre-install position, moving it ever gently and ever methodically to what is called a ready-to-latch position, in which the two docking mechanisms on the interface between the HTV and the Earth-facing port of Harmony will barely come into contact with one another, essentially overlapping each other to begin the latching and bolting process. There are a series of 16 bolts on the active common berthing mechanism on the Harmony side of this berthing interface, 4 gangs of 4 latches apiece that will be bolted down first by the station crew that will do the initial bolting procedures. Karen Nyberg and Chris Cassidy in charge of that. They'll be sending commands through a laptop computer to do what is called the initial bolting, or the A bolts, that form what is called a first stage capture of the HTV to the common berthing mechanism on Harmony. And then the ground will take over, working in concert with the crew to do the final bolting procedure in what is called second stage capture, and that under the supervision of the Operations and Support Officer, or the Mechanical Systems Officer here in Mission Control, will complete the final mating of the HTV-4 to Harmony and affix it permanently to the station over the course of the next 4 weeks or so. The HTV-4 began its final rendezvous much earlier this morning in the deep overnight hours with a series of rendezvous burns that were carefully choreographed, a very methodical approach of the HTV-4 as it began to track its way towards a position some 1,000 feet directly below the International Space Station along what is called the R-bar, or the radial vector, the imaginary line drawn between the International Space Station and the Earth. Slowly but surely, the HTV-4 made its way up the radial vector, passing through a series of intermediate checkpoints so that the flight control team at the JAXA Flight Control Center in Tsukuba, Japan, could check out the HTV's systems, ensure that everything was in good shape, and to enable the crew on board the International Space Station to monitor the approach of the HTV from the cupola robotics workstation in the ISS so that they could ensure that we would have a precise alignment with the HTV-4 moving up the narrow corridor for its ultimate grapple by Karen Nyberg. You're looking at video that was acquired just a little under 2 hours ago as the HTV moved from a point just 30 meters away from the International Space Station to a capture point just 30 feet away, at which point Karen Nyberg extended the Canadarm2, the station's robotic arm, ever so slowly with the latching end effector moving over the grapple pin on the grapple fixture of the HTV and latching it into place at 6:22 a.m. Central Time, 7:22 a.m. Eastern Time. Once the HTV is mated and bolted into place on the nadir side of the Harmony module, the Earth-facing side of Harmony, the crew will then have an opportunity to move into what is called vestibule operations. They will begin to outfit the small passageway between the International Space Station and the HTV at the docking interface itself. There will be leak checks that will be performed, but the actual hatch opening will not take place to the HTV until tomorrow morning, Saturday morning, when the crew will open up the hatch to HTV and begin to unload the so-called pressurized cargo that is inside the spacecraft itself, housed in racks. The HTV-4 is equipped with more than 3.5 tons of equipment, some 4,100 pounds of dry cargo. You're looking at some of that cargo in the form of experiment hardware, spare parts, and other supplies for the Expedition 36 crew on the International Space Station. The HTV inside is also carrying 24 bags of water, or some 1,300 pounds of water, to resupply the water provisions on board the complex. Outside the HTV cargo craft, in a slot on the side of the spacecraft, is called the exposed pallet. This is a pallet that will be extracted by ground commanded robotics on Sunday night, in which the ground controllers here in Houston will remove the exposed pallet from that slot on the side of the HTV as depicted in this animation, maneuver it around to hand that pallet off to the Japanese robotic system, the Japanese robotic arm on the end of the Kibo module. That handoff will then enable ground controllers in Tsukuba, Japan, to install this exposed pallet onto the front porch or the exposed facility on the outside of the Kibo module, after which the items that are on that exposed pallet will be plucked off one by one in the days and weeks ahead for installation on various locations on the truss of the International Space Station. Included in the complement of cargo on that exposed pallet that will be extracted from the side of the HTV on Sunday night are a main bus switching unit, an electrical component that routes power from the station's power system through the solar arrays to power various systems on the station. That main bus switching unit spare will be temporarily installed on an external stowage platform on the truss of the International Space Station. There is also a utility transfer assembly that will be ultimately used at one point as a spare part for the solar alpha rotary joint on the station's solar array system. That will be installed temporarily on an express logistics carrier on the outside truss of the station, and a suite of experiments, material science experiments for the Defense Department called the Space Test Program. That suite of experiments will be installed on another express logistics carrier on the truss of the station as data will be gathered by researchers here on the ground at the Johnson Space Center. A similar suite of experiments called the Space Test Program 3 will be removed from its location on the truss of the station, put back on that exposed pallet, reinstalled into the slot of the HTV, and discarded after the HTV is unberthed and cast away on September 4th in the same robotics activity that will be conducted in reverse, if you will, to what we're seeing today as the HTV is unberthed and released to move away to a safe distance from the International Space Station for an expected deorbit on September 7th, 3 days after its unberthing, and a deorbit that will result in a fiery breakup over the Pacific Ocean. At that point, the HTV will be loaded with trash and items no longer needed on the International Space Station. The International Space Station and its crew of 6 currently flying 260 statute miles above the Earth on a track taking it from southwest to northeast, just off the coast of Somalia, soon to pass to the south of the Saudi Peninsula and over the west coast of India on this particular orbit of the Earth. On board the International Space Station, the commander of the station, Russian cosmonaut Pavel Vinogradov, and his crewmates, Alexander Mazurkin and Chris Cassidy, who flew together up to the station on the Soyuz TMA-08M spacecraft, their launch occurring 134 days ago, back on March 29th from the Baikonur Cosmodrome in Kazakhstan. They are due to return to Earth in that Soyuz spacecraft on September 10th, U.S. time, the morning of September 11th, Kazakhstan time, for a parachute-assisted landing on the south-central steppe of Kazakhstan. The other trio on board the station, flight engineer Karen Nyberg of NASA, Russian cosmonaut Fyodor Yurchikhin, and European Space Agency flight engineer Luca Parmitano, launched on their Soyuz TMA-09M spacecraft from Baikonur 73 days ago, back on May 29th, arriving on the station some 6 hours later and joining Cassidy, Mazurkin, and Vinogradov. This trio is not scheduled to return to Earth until November 10th U.S. time, November 11th in Kazakhstan in their Soyuz spacecraft. While all of this robotics activity and the rendezvous of the HTV for its grapple that occurred about 2 hours ago has been taking place on board the station, Russian cosmonauts Fyodor Yurchikhin and Alexander Mazurkin have been busy continuing their preparations for a spacewalk outside of the Pirs docking compartment 1 week from today on Friday, August 16th, in Russian Orlan spacesuits, in which they will continue to hook up cabling that will be a preparatory activity for the future arrival of a new Russian laboratory module. They'll also be installing a panel of material science experiments on the Poisk module. They will continue their spacewalking exploits 6 days after that on August 22nd with yet another spacewalk out of the Pirs docking compartment, again in Russian Orlan spacesuits, in which they will remove a laser communications system experiment from the outside of the Russian segment of the complex and install a rotating platform that will be used for the future installation of a small optical telescope to be mounted on the hull of the Russian segment of the International Space Station. In all, the next two spacewalks by Yurchikhin and Mazurkin will be the 172nd and 173rd spacewalks in support of space station assembly and maintenance, the 7th and 8th in Yurchikhin's career, and the 2nd and 3rd for Mazurkin. The two ventured outside the Pirs back in June, late June, for a spacewalk that preceded the pair of EVAs that are upcoming, again on August 16th and 22nd. This unique choreography of crew and ground-controlled interaction in today's activities again began with Karen Nyberg and Chris Cassidy operating from the Cupola Robotics Workstation aboard the International Space Station. Nyberg was at the controls of the Canadarm2 robotic arm as she reached out and grappled the HTV-4. At that point, she handed over the robotics activities to the ground controller here in Mission Control in Houston, called the Robo. That is John Bellingham for this shift of flight controllers. Bellingham maneuvered through commanding the Canadarm2 into a position to be able to provide Chris Cassidy a view of the common berthing mechanism known as the PCBM, the passive side of the latching mechanisms between the HTV-4 and the Harmony connecting node to which the HTV will be installed and bolted into place a short time from now. Cassidy reported that the surfaces of the passive common berthing mechanism on the HTV cargo craft were all clean. Everything looked in good shape. And so we're at a pause here in the activity, but we will resume here any old time now, just momentarily, where the robotics officer here in Mission Control will resume the maneuvering of the HTV to what is called the pre-install position, and then ultimately into a ready-to-latch position in which essentially the two docking mechanisms on the HTV and again on the Harmony module will essentially overlap one another, providing a ready-to-latch indication for the crew on board who will be operating the initial bolting of the HTV into place onto Harmony through a laptop computer aboard the International Space Station. As the flight control team here in Mission Control continues the preparations prior to the maneuvering of the HTV-4 to its pre-installed position by the Harmony module to which it will be connected a short time from now. The HTV-4 journey to the International Space Station began almost 6 days ago with a Earth-rattling launch from its Oceanside launch pad in Tanegashima, Japan, on the southern coast of Japan. The H-2B rocket lit up at 2:48 and 46 seconds p.m. Houston time on Saturday, August the 3rd, which was 4:48 and 46 seconds a.m. Japan time at Tanegashima. The H-2B took flight, arced out away from the Oceanside launch pad in southern Japan, and 15 minutes later deposited the HTV-4 as it separated from the second stage of the rocket to begin its lengthy journey en route to the International Space Station. Over the course of the next 6 days, the HTV-4 conducted a variety of rendezvous burns through its primary engines and its 28 reaction control system jets. All of that activity carefully choreographed and pre-programmed that resulted in the grapple of HTV by astronaut Karen Nyberg using the Canadarm2 robotic arm 2 hours ago at 6:22 a.m. Central Time, 7:22 a.m. Eastern Time. This is Mission Control Houston. It's probably worth mentioning at this point that while the HTV-4 will spend a month bolted to the International Space Station to permit its 3.5 tons or so of cargo to be unloaded, both internally and externally by robotics, to be used by the Expedition 36 crew on board the International Space Station. The HTV-4 will be re-grappled by the robotics team here in Mission Control on September 4th. Unbolted from its berthing port on the Earth-facing side of Harmony, and then released in reverse fashion of what is happening today to move to a safe distance away from the complex for a deorbit burn on September 7th that will send HTV-4 plummeting back into the Earth's atmosphere and filled with trash to burn up in the Earth's atmosphere over the Pacific Ocean. That activity will then open up the Earth-facing port of Harmony for the next cargo ship to be launched. This one by Orbital Sciences Corporation, the new Cygnus resupply craft, to further augment a U.S. cargo carrying capability to the International Space Station in the wake of the successful flights of the SpaceX Dragon craft to the complex in the last couple of years. The Cygnus is to be launched on a Antares rocket from the Wallops Flight Facility on the coast of Virginia in the mid-September time frame. There will be reviews of the preparations for launch that will take place in the late August, early September time frame that will lead to the formal establishment of a launch date for Cygnus and its methodical approach over the course of a period of time to be grappled again by the station crew and mated into place on the Earth-facing port of the Harmony node. A look inside the International Space Station. Chris Cassidy floating into the Unity module to join Karen Nyberg and Luca Parmitano as they begin to get set up to monitor operations as the robotics officer here in Mission Control has begun to maneuver the HTV-4 into its pre-install position. This will be a very slow and glacial activity that will precisely align the two berthing mechanisms, the common berthing mechanisms, both on the HTV-4 and on Harmony, so that the cargo craft can be carefully aligned to a ready-to-latch position over the latches on the common berthing mechanism on Harmony. The crew on board the station that you're looking at, working from a laptop computer aboard the station, will begin the initial bolting procedures. Again, there are 16 bolts that will hard mate, if you will, the HTV-4 to Harmony. They're in 4 gangs of 4 bolts apiece. And the first stage of bolting, called A bolts, will form what is called first stage capture. Then the ground takes over, and the operations and support officer, or the OSO position here in Mission Control, will then take over the final latching for second stage capture, at which point the HTV-4 will be hard mated to the International Space Station. Later today, Chris Cassidy and Karen Nyberg will take on the lion's share of work as they begin to outfit the vestibule, the small passageway between Harmony and the HTV-4, in preparation for the opening of the hatch that will take place around 6:30 a.m. Central Time on Saturday, and subsequent robotics by the robotics ground controllers here in Mission Control on Sunday evening, in which they will extract a pallet of spare parts and experiments from a side slot on the side of the HTV-4, hand off that exposed pallet, as it is called, to the Japanese flight control team in Tsukuba, Japan, that will take over with the Kibo remote manipulator system, the robot arm on the side of the Kibo, that will take a handoff from the Canadarm2 and install that exposed pallet of experiments on the exposed facility, or the front porch of Kibo, to which a variety of experiments are mounted and are used for long-term experiment activity that is monitored 24 hours a day, 7 days a week by the flight control team in Tsukuba, Japan. So a working lunch for the three of the crew members on board the International Space Station, Luca Parmitano, Chris Cassidy, and Karen Nyberg, inside the U.S. segment of the International Space Station as they continue to prepare for the monitoring of the installation to a ready-to-latch position of the huge HTV-4 spacecraft, 30 feet in length, 16.5 tons in mass, carrying more than 3.5 tons of cargo for the Expedition 36 crew. The International Space Station currently flying 260 statute miles over far eastern Russia. About to begin a northwest to southeasterly track across the Pacific Ocean and into an orbital sunset. Here in Mission Control, the robotics officer, John Bellingham, is in the process of carefully sending commands to maneuver the HTV-4 at the end of the Canadarm2 into what is called a pre-install position. There will be varying checkpoints along the way to measure the alignment of the berthing mechanism on the end of the HTV-4 that is known by the Japanese name Konotori, the Japanese word for white stork. That common berthing mechanism will be precisely aligned with a similar berthing mechanism on the Earth-facing port of Harmony, and then slowly slipped into place to a ready-to-latch position to enable the bolting of the cargo ship to begin. As the very slow and deliberate movement of the HTV-4 continues under the handle of the robotics officer, John Bellingham, here in Mission Control, to the pre-install position on the Earth-facing side of the Harmony module, you're continuing to look at the crew inside the Unity module, Node 1 as it is called, in this view from a camera set up in the Destiny laboratory looking through Unity, and the bags of cargo that you see stowed right behind Luca Parmitano there, that is the entrance to the Zarya module and the connecting point, the junction between the U.S. and Russian segments of the International Space Station. Zarya, the first element of the International Space Station that was launched from the Baikonur Cosmodrome in Kazakhstan almost 15 years ago on November 20th, 1998, followed a month later by the launching of Unity on the STS-88 mission aboard the shuttle Endeavour, and the first actual assembly work that took place to connect Zarya with Unity on a mission that was commanded aboard Endeavour by the now director of the Kennedy Space Center, Bob Cabana. The maneuver that is taking place, although barely perceptible by the robotics officer here in Mission Control to what is known as the pre-install position, will then be followed in kind with the actual installation work, in which the robotics officer will continue to maneuver the Canadarm2 in the firm grasp of HTV-4 into the pre-install position. Along the way, there will be varying checkpoints. You can see this view through a camera that is known by the acronym of CBCS. That's the Centerline Berthing Camera System. This provides visual cues for the robotics officer here in Mission Control, John Bellingham, to be able to monitor the alignment of the common berthing mechanism, the passive side of it on the HTV spacecraft itself, with the active common berthing mechanism on the Earth-facing side of Harmony.
On fill station on station round 2.
Go ahead on 2.
Just wondering if it's okay for me to pick up in the MSG activation.
Karen, you bet it is. Go for it.
Karen Nyberg, who about 2 hours ago was at the controls at the robotic workstation in the cupola, reaching out and grappling the HTV-4 spacecraft to complete its journey of almost 6 days from the launch pad at Tanegashima, Japan, to the International Space Station. Nyberg then yielding those controls over to the robotics officer here in Mission Control. Now she presses on for research work on board the station while the HTV-4 is in the process of maneuvering to its installed position. She is going to be powering up the microgravity science glove box in the Destiny laboratory to enable payload controllers at the Payload Operations Integration Center in Huntsville, Alabama, to continue gathering data on the in-space experiment.
2 for thruster configuration and exercise constraint.
Right on 2.
Hey, Chris, we are going to disable the thrusters, so no exercise constraint comes earlier than once it's done, HTV special LOAC safing procedure is in play, and it is linked in the IPV. Hard copy.
Okay, I think I understand. No exercise starting right now, and we copy the LOAC delta.
Good copy.
Spacecraft communicator Takuya Onishi here in Mission Control, reporting to Chris Cassidy on board the International Space Station that the time has come for the disabling of thrusters on the International Space Station and the constraints on exercise on board the complex while we move into the more critical phase of the fine-tuning of the maneuvering of the Canadarm2 into the pre-install position for the HTV to be mated to the Earth-facing port of Harmony. Meanwhile, Karen Nyberg again will be powering up the microgravity science glove box in the Destiny laboratory for more data takes on the in-space experiment. In-space is an acronym for investigating the structure of paramagnetic aggregates from colloidal emulsions. Essentially, it's an experiment that obtains data on fluids that contain ellipsoid-shaped particles, which in turn change the physical properties of the fluids in response to magnetic fields that are experienced in the microgravity environment of space. You're looking at varying views from both external cameras on the International Space Station and the centerline common berthing mechanism camera, views that are being provided to the robotics systems officer here in Mission Control as the maneuvering of the station's robotic arm continues to align the HTV-4's common berthing mechanism with a similar berthing mechanism on the Earth-facing side of Harmony. We're not quite there yet. This is a very deliberate maneuver, very carefully choreographed on the ground so that we have a precise alignment between the two berthing mechanisms in what is known as the ready-to-latch configuration that will enable the crew on board the station initially, followed by ground controllers here in Mission Control to bolt the HTV-4 in place.
The MSG is activated, and I'll be ready to pick up in the operation of test perimeter 103 or test 103 whenever you guys would like me to.
And Karen, you have a go to proceed.
Or thanks.
Here in Mission Control, it has been confirmed that thrusters have been disabled on the International Space Station, and the robotics officer now will press ahead to move the HTV-4 inside 2 feet of the berthing interface with the Earth-facing port of the Harmony module.
So station on 2, I have the lab camera up on the MSG if you're interested and able to watch along.
We copy and we are following along. Thank you.
And again, while the robotics takes place to make the HTV-4 a permanent fixture on the International Space Station for the next month, you're looking over the shoulder of Karen Nyberg, who about 2.5 hours ago was at a different location in the cupola of the International Space Station, operating Canadarm2 to reach out and grapple HTV-4 and complete its 6-day journey from the launch pad in Tanegashima, Japan. Now she switches from a robotics operator to a researcher on board the International Space Station. She sets up the microgravity science glove box in Destiny for the operation of the in-space experiment. as the International Space Station flies over the Pacific Ocean to the southeast of the Hawaiian Islands. Karen Nyberg working in the Destiny Laboratory, preparing the samples for the next data takes in the in-space experiment. You're looking over her shoulder into the microgravity science glove box in Destiny, which houses a variety of research activities for the payload controllers at the Marshall Space Flight Center in Huntsville, Alabama. This is Mission Control Houston, all quiet here in the flight control room as the robotics officer continues to slowly maneuver the Canadarm2 to a pre-installed position just a couple of feet away from the common berthing mechanism on the Earth-facing side of the Harmony module. Karen Nyberg there you see working in the microgravity science glove box, setting up equipment for more data takes with the in-space experiment, while all of this other robotics work takes place simultaneously. Once in the pre-install position, flight controllers will monitor the precise alignment of the berthing mechanism on the HTV with a comparable berthing mechanism on the active side on the Harmony module itself before the robotics officer here maneuvers the arm ever so slowly to what is called a ready-to-latch position, essentially virtually the mating position between the two surfaces of the common berthing mechanisms that will initiate the bolting of the HTV into place. And a view from the centerline common berthing system camera that again is providing alignment views for the robotics officer here in Mission Control, John Bellingham, as he works to precisely align the HTV-4's common berthing mechanism with the comparable twin of that CBM on the Earth-facing side of Harmony.
Go ahead.
And the square wave generator mode was to standby at 1401.
That's full copies. Thanks.
A good view from a camera on the truss of the International Space Station showing HTV-4, 30 feet in length, 14.5 feet in diameter, 16.5 tons in mass, hovering over the common berthing mechanism on the Earth-facing side of Harmony. The International Space Station flying 260 statute miles over the South Pacific, about to enter an orbital sunrise. Here in the flight control room, the robotics officer, John Bellingham, has reported to Flight Director Judd Freeling that they are working to fine-tune the alignment of the HTV-4 berthing mechanism with that of the Harmony module, to which it will be attached a short time from now. Housed aboard the HTV-4, some 3.6 tons of cargo, 4,100 pounds of dry cargo inside as pressurized volume, as it is called. That is comprised of spare parts and experiment hardware and supplies for the International Space Station Flight Control Team and crew, some 24 bags of water, about 1,300 pounds of water in all, and externally as unpressurized cargo housed on an exposed pallet, as it is called, in a side slot on the body of the HTV itself, two critical spare parts, a main bus switching unit and a utility transfer assembly unit, and a suite of experiments for the Defense Department called the Space Test Program 4 experiment for the Department of Defense's office here at the Johnson Space Center. Those spare parts and the Space Test Program payload will be affixed to varying points along the truss of the International Space Station, the spare parts to be used if required in the future. The Space Test Program to spend several months acquiring data on the effect of the microgravity environment on samples of materials. Whether it is handled by the crew on board the International Space Station or by the robotics officer here in Mission Control, we are at some of the more complex work involved in the mating of this large cargo ship to the International Space Station. The alignment of the HTV-4's berthing mechanism to that on the Harmony module is a time-consuming process that will be the precursor to the actual bolting of the cargo ship in place to Harmony, where it will spend the next 4 weeks, enabling the crew on board the station to unload more than 3.5 tons of cargo.
Unfill station on 2, experiment start time is 14:10.
Huntsville copies, experiment start time 14:10. Thanks again, Karen.
Having passed into an orbital sunrise, the International Space Station, with the HTV-4 hovering just a short distance above its destination, that being the Earth-facing port of the Harmony module, moving from northwest to southeast, approaching the southwestern coast of South America, soon to cross over the Andes Mountains, and then swing back across the South Atlantic on this particular orbit of the Earth. The robotics systems officer here in Mission Control continues to align the HTV-4's common berthing mechanism with the similar mechanism on the Harmony side of that berthing interface, so that we can move into a ready-to-latch position and begin the bolting of the cargo ship into place.
I'm still stationed on Spacegram 2.
This is Huntsville. Go ahead.
I am complete through step 4-8. Just wondering if you have good views on the ground of this, or if you need any description of what I'm seeing.
And Karen, the in-space PDs are happy, so you have a go to press. But thanks for checking with us.
All right, I'll give it 20 minutes and then come back for step 5.
That sounds like a great plan.
To recap the morning's activities, a flawless rendezvous for the Japanese HTV-4 cargo ship to the International Space Station. All of the rendezvous maneuvers were executed in fine fashion with no issues and no systems problems reported at all. The HTV-4 arrived about 1,000 feet directly below the International Space Station, slowly but surely executed all of its rendezvous burns to maneuver its way up the so-called R-bar, the radial vector, that being the imaginary line that is drawn between the International Space Station and the Earth. It inched its way up the R-bar to a point just 30 feet away from the station, stopping at varying checkpoints to enable its systems to be monitored to ensure that it was in a good configuration for its ultimate capture, at which point Karen Nyberg, operating from the cupola workstation, the robotics workstation in the cupola, maneuvered the station's Canadarm2, reached out and grappled the grapple fixture on the HTV-4 cargo ship. A firm grasp initiated between the robot arm's latching end effector and the HTV-4 grapple fixture itself. At that point, she turned over the robotics activities to the robotics ground control team here in Mission Control, led at this hour by the Orbit 2 team, Robo, as the position is called, John Bellingham, who maneuvered HTV-4 into an inspection position. Everything was found to be in good shape with its common berthing mechanism, no foreign object debris, and nothing that would preclude a smooth installation of the HTV-4 onto the common berthing mechanism on the Earth-facing side of Harmony. You're looking at a view right now as HTV-4 is hovering just above that common berthing mechanism as Bellingham is working to precisely align the two berthing mechanism interfaces between the HTV-4 and the Harmony module before moving it into a ready-to-latch position for the bolting of the cargo ship into place. This is Mission Control Houston. Here in the flight control room, the robotics officer is going to take a break for just a few minutes while we wait for a handover between our tracking and data relay satellite system and the ability to have a downlink television capability from the station that will provide the views that you're looking at through the centerline common berthing mechanism system. This alignment process requires a video capability, so the robotics officer here in Mission Control can monitor the alignment of the common berthing mechanism on the end of the Kanatori 4 or the HTV-4 cargo ship with the common berthing mechanism on the Harmony module. We're getting close. Again, a slow and methodical process at this point to provide a fine alignment, a precise alignment that will enable the HTV-4 to slip into the capture envelope of the common berthing mechanism, provide a ready-to-latch indication for the crew on board the station that will be their cue to begin bolting the HTV-4 in place. They will conduct the initial bolting, the A-bolts as they are called, for a first stage capture of the HTV-4 from a laptop computer aboard the International Space Station, then hand the process back off to the flight control team here in Houston, where the operations and support officer, the mechanical systems officer, if you will, here in Mission Control, will complete the bolting for the second stage capture that will firmly mate the HTV-4 in place at the International Space Station.
Station Houston on 2 for Karen for your SSC problem.
Go ahead on 2.
Hey Karen, in order to troubleshoot on your IP viewer problem, we would like to go on board to your SSC in order to clear a cache around 1432. So please make sure hands off your SSC by the time.
Okay, I'll be hands off in about 5 minutes then.
Thank you very much.
This is Mission Control Houston. The robotics officer here in Mission Control, John Bellingham, continues to fine-tune the alignment of the common berthing mechanism at the end of the Japanese H-2 transfer vehicle, the HTV-4, with the companion berthing mechanism on the Earth-facing port of the Harmony module. You can see in this view from the centerline common berthing system camera that provides the visual cue that Bellingham, the robo as he is called by his handle here in Mission Control, is using for the fine-tuning of that alignment before he moves the HTV-4 into what is known as a ready-to-latch position to initiate the bolting of this huge cargo craft into place on the Harmony node. The International Space Station currently orbiting 260 miles above the Earth, moving from southwest to northeast, approaching the west coast of Africa. And the robotics officer here in Mission Control has reported to Flight Director Judd Freeling that he is happy with that alignment of the two berthing mechanisms and will now move to a surface-to-surface position just before we get to that ready-to-latch indication.
Console Station on 2.
This is on 2. Go ahead, Karen.
With the run operations, and I guess I'll be coming back to it in a couple hours.
That is correct. We'll see you in a few hours.
Once again, here in Mission Control, flight controllers under the direction of Flight Director Judd Freeling watching over their console position displays, monitoring space station systems in support of the ultimate berthing and latching in place of the HTV-4 cargo ship that was grappled just over 3 hours ago by Karen Nyberg, operating the Canadarm2 robotic arm, affixing the grapple fixture onto the grapple pin on the HTV-4 itself at 6:22 a.m. Central Time, as HTV-4 and the International Space Station flew to the south of South Africa. The robotics officer here in Mission Control continuing to fine-tune the alignment of the two berthing mechanisms as we move the HTV-4 into a surface-to-surface orientation. That will be the precursor to slipping the HTV-4 into a ready-to-latch position and the initiation of the bolting between the two common berthing mechanisms to firmly affix the HTV-4 onto the Earth-facing port of Harmony.
Station Houston on 2 for Karen for your SSC.
Go ahead.
Hey, we did go on board your SSC and cleared some cache files and verified with 3 iView procedures that it's working nominally right now. So can you verify that? Then please let us know if you have any problems.
Okay, I'll check it out.
Thank you.
Houston Station on 2, it appears to be working just fine. Thank you guys so much for fixing that. As much as I love the in-space science, it was getting strange opening that procedure every time I opened something on OSTPV. Thanks again.
And we copy. That's good news. Thank you very much. Station Houston on 2 for Chris for HTV status.
Korea, go ahead.
Hey Chris, we have a little bit some problems with alignment. Then we are getting a little bit late from the timeline. So our estimate is we will be able to give you a go for first stage capture around 15:25.
Okay, copy all. I'll be here, of course, and ready to work whenever you get things sorted out. No rush, and sorry to hear you're having trouble.
And thank you. And station Houston on 2 for Luca.
This is Luca. Go ahead.
Okay, so if you want to get ahead a little bit earlier, so you can perform your vestibule pressure activity. That's Eagles Book procedure 2.805. You can perform through up to and including step 4.3 at your convenience. No rush.
Copy up to 4.3 of the vestibular procedure, and I will be starting in about half an hour. I'm doing a task list item right now.
We copy. Thank you very much.
This is Mission Control Houston. You heard just a few moments ago spacecraft communicator Takuya Onishi here in Mission Control reporting back to Chris Cassidy that the alignment of the common berthing mechanism on the HTV-4 cargo ship with the common berthing mechanism on the Earth-facing port of the Harmony node, to which the HTV-4 will be connected and bolted into place a short time from now, is taking a bit longer than had been expected as they continue to work to fine-tune the alignment of those two berthing mechanisms with one another before moving into what is called a ready-to-latch position. As such, we are about maybe 30 minutes away from initiating the bolting of the Japanese cargo ship to Harmony. And so with that very slight delay in the procedures, we can recap for you the events that have taken place over the past 6 days. The HTV-4 began its journey to the International Space Station with a pre-dawn launch on Sunday, August 4th, Japan time, from the Tanegashima Space Center on the southern coast of Japan. Atop an H-2B rocket. The rocket left the launch pad at 2:48 and 46 seconds p.m. Central Time on Saturday, August the 3rd, which was 4:48 in the morning Japan time on Sunday, August 4th.
From the Tanegashima Space Center at 4:46 a.m. on August 4, 2013, Japan Standard Time.
And 35 seconds into the flight, and the familiar scream of the...
And as you can hear, that replay of the launch showing the H-2B rocket leaping away from its launch pad, lighting up the night skies off the Oceanside launch pad in Tanegashima. 15 minutes later, the HTV-4 was placed into its preliminary orbit after its separation from the second stage of the H-2B rocket. The course of the next 5.5 days saw the HTV-4 conduct a series of pre-programmed engine firings through its primary engines and its 28 reaction control system jets to fine-tune its path to the International Space Station. In the wee hours this morning, the HTV-4 arrived at a point directly below the station, about 1,000 feet below the station, along what is known as the R-bar, or the radial vector to the Earth, the imaginary line drawn between the space station and the Earth, and slowly but surely it inched its way up the R-bar, or the radial vector, towards the space station, stopping at several hold points to enable flight controllers at the Japan Flight Control Center in Tsukuba, Japan, to monitor the station's systems. Here in the flight control room, the International Space Station Flight Control Team also conducted several polls along the way to ensure that the HTV systems were in good operating order. And then finally, the HTV reached a final hold point just 30 feet away from the International Space Station. Flight engineer Karen Nyberg, backed up by Chris Cassidy on the cupola workstation of the International Space Station, operated the Canadarm2 robotic arm, reached out and grappled the large spacecraft, 30 feet in length, 14.5 feet in diameter, with a mass of more than 16 tons, reached out and grappled HTV-4 at 6:22 a.m. Central Time, 7:22 a.m. Eastern Time, as the two spacecraft flew some 260 miles south of South Africa. At that point, the crew went hands-off on the robot arm, turned over the robotics work to the ground controllers here in Mission Control, who maneuvered HTV-4 into an inspection orientation, enabling Chris Cassidy to take a look at the passive common berthing mechanism on the HTV-4 itself, make sure that there was no debris or any foreign objects that could interfere with the clean installation that, again, is coming up within the next half hour. The robotics controller here in Mission Control, John Bellingham, has been maneuvering the station's robotic arm by ground-commanded control into a position to align the two common berthing mechanisms on the Japanese cargo craft and the Harmony node, Earth-facing port, to which it will be connected a short time from now. That alignment has taken slightly longer than had been planned, and we expect to be in a position in what is called a ready-to-latch position to begin the bolting of the spacecraft into place in about 25 minutes or so. So while we continue to wait for that alignment to be fine-tuned. We can tell you that the crew on board the International Space Station, from left to right, Alexander Mazurkin, Pavel Vinogradov, Chris Cassidy, Luca Parmitano, Fyodor Yurchikhin, and Karen Nyberg, have been conducting other work since the grapple of HTV-4. Nyberg set up the in-space experiment and the microgravity science glove box in the International Space Station's Destiny Laboratory. Earlier today, Yurchikhin and Mazurkin continued to review procedures and timelines and check out the Russian Orlan spacesuits they will wear for the next spacewalk to be conducted out of the station's Pirs docking compartment and its airlock a week from today on August 16th, in which Yurchikhin and Mazurkin will continue to connect cables in preparation for the future arrival of a Russian laboratory module to be launched no earlier than December of this year on a Russian Proton rocket, and a subsequent spacewalk on August 22nd to remove a laser communications experiment from the outside of the Russian segment of the station and to install a rotating work platform upon which a small optical telescope will be installed in the future. This crew of 6 on board the International Space Station comes from a varied background with a wealth of experience and a variety of skills that are being brought to this international laboratory for their work in support of space exploration. Let's take a look at this crew, the Expedition 36 crew on board the International Space Station.
The members of the International Space Station crew all believe that their 6-month mission is an important part of the work that's needed to help human beings continue to explore well beyond their home planet. Pavel Vinogradov was born in the far eastern Russian town of Magadan and grew up in the even farther eastern town of Anodir, just 500 miles across the Bering Sea from Nome, Alaska.
If you have been to Alaska, then it's pretty much the same. The nature is just fantastic. Of course, the climate is very harsh, 8 months of winter, lots of snow and ice, but I love it. I enjoy it.
After a childhood spent dreaming of becoming a pilot, Vinogradov left Anodir after high school for the Moscow Aviation Institute. He earned a degree in rocket booster design, then taught and did research at the institute while earning a second degree in computer systems and systems analysis. Vinogradov joined the design bureau of the Rocket Space Corporation Energia in 1983 and worked on the Mir space station, the Buran shuttle, and other Energia vehicles before being selected to Energia's Cosmonaut Corps in 1992. He logged 198 days in space as the board engineer on Mir 24 and made 5 spacewalks to repair Mir after a Progress freighter punched a hole in it in the summer of 1997. He made one more spacewalk in 2006 as commander of the International Space Station's Expedition 13, a 183-day mission that restored the station's crew complement to 3. He believes today's space exploration efforts bear comparison to the sea voyages of the great explorers in the Age of Discovery.
People who were exploring the Earth did not know that they will discover America in 4 months, for example. The risks were great. But I have no doubt that likewise, we, as those explorers, we need to explore space.
Retired Russian Air Force Lieutenant Colonel Alexander Mazurkin is a product of Western Russia, born in Yurshy-Chi in the Smolensk region and raised a couple of hundred miles away in Oryol. He calls his childhood a typical one and says even as a young boy, he wanted to go places no one had been to before.
I wanted and decided to be a cosmonaut when I was a little boy. When I was a 13 years old guy, I went to the aviation club. There I made parachute jumping. There I was flying on gliders.
Becoming a pilot was next on his list. After school in Oryol, Mazurkin went to the Kasha High Air Force Pilot School in Volgograd, then finished his pilot training at the Armavir Military Aviation Institute in Krasnodar in southern Russia. He spent the next 7 years in the Russian Air Force as a pilot instructor at the Krasnodar Military Aviation Institute before being selected as a cosmonaut in 2006. Mazurkin shares the philosophical view of the Russian rocket science pioneer Konstantin Tsiolkovsky, who believed that Earth is the cradle of humanity, but that mankind can't stay in the cradle forever.
He was positive that we are going to the space and we will live in in other worlds, in other different places, and the time will come in for this, I'm sure. That is why I think we should do this job.
U.S. Navy Commander Chris Cassidy is a native of Salem, Massachusetts, who grew up in York, Maine, on the Atlantic coast. He was aware of the space program as a young boy, but admits he wasn't particularly interested.
I was just like every other boy. I mowed lawns, had a couple odd jobs in restaurants and things in the summertime, but that was all to really pay my gas to drive to the basketball court.
Cassidy left York after high school, first for a year at the Naval Academy Prep School, and then on to Annapolis, where he earned a bachelor's in mathematics. Next stop was San Diego to begin training in special operations as a Navy SEAL. After 4 years stationed in Virginia, he earned a master's in ocean engineering at MIT. And about that time, he became aware of a fellow Navy SEAL who'd had a similar career arc to his, astronaut Bill Shepard.
So one day I actually met him or called him, and he gave me some great information, and I thought, you know what, that sounds really like a really fun job. I think I'd like to do that. So I was probably 26 or 27 when the idea first popped into my head.
Cassidy applied, but didn't get the call from NASA. The next year, just weeks after September 11th, the SEAL platoon he commanded did get the call, and he was deployed to the Afghanistan region before the 1st of October. He returned home to another posting in Virginia, and he was selected for the astronaut program in 2004, just days after coming home from a second deployment to Afghanistan. Cassidy made 3 spacewalks on his first trip to the International Space Station on the 2009 Space Shuttle mission that delivered the components to complete construction of the Kibo Laboratory Complex. He's enthusiastic about his part in laying the groundwork for some future generation of Earthlings to fulfill their destiny to find a new home in space.
But there'll be a time when there'll be people living on other planets. And it's the work, the hard work that we're doing right now, all of us across the globe, that are going to set the stage for that type of environment. Just like Christopher Columbus set sail one day across the ocean. And thanks to those great explorers, we live the life that we do today.
Fyodor Yurchikhin was born and raised in the Black Sea port city of Batumi in Soviet Georgia, growing up in a time and place where all the children wanted to be cosmonauts, where the winners of kids' games were called Gagarins. Yurchikhin wanted to be a part of that life, even if he couldn't be a dashing test pilot.
For what reason I understood maybe in this time, then it's maybe in my health, it's not enough to be a cosmonaut, but what is more important for me, be a pilot or be an engineer in space program. Of course, the space program, it was too important for me.
So after high school, Yurchikhin went to the Moscow Aviation Institute, earned a bachelor's degree in mechanical engineering, specializing in aerospace vehicles, and went straight to work for the Rocket Space Corporation Energia as an engineer. He worked as a flight controller, and when he became lead engineer for the Mir shuttle program, he spent time at NASA's Johnson Space Center supporting that effort. Yurchikhin was selected as an Energia cosmonaut in 1997 and earned a Ph.D. in economics at Moscow Service State University while preparing for his first spaceflight. He was a member of the STS-112 crew that delivered a piece of the station's starboard truss during Expedition 5 in 2002. He returned 5 years later on a Soyuz spacecraft as commander of Expedition 15 and made 3 spacewalks, and followed that with 2 more EVAs as a station flight engineer on Expeditions 24 and 25 in 2010. He believes the station program is paying off in the things we're learning while making the effort, from improving the spacecraft themselves to the tools we develop.
But the first big, exactly great sensor for digital cameras, it was factored for this program. And now it's usual for everybody. It's usual for my daughters. It's usual for young boys and girls. I know my profession, it's very important for human. Why I am on this road.
Italian Air Force Major Luca Parmitano is from Sicily, born in Paterno and raised in Catania in the shadow of Mount Etna. Although he was very young when he saw the first space shuttles fly on television, he was captivated by the idea of what those images represented.
So I remember seeing the first astronauts floating around the space shuttle doing their job. And I think that even in a kid, as small as I was, I just thought that must be the greatest job in the world to be able to do those things and call it a living. So since then, I had this dream of becoming an astronaut.
Parmitano won a scholarship to spend a year of high school in Southern California. In that year in America, he not only intensified his desire to be a pilot by living with a host family in which the father was a marine navigator, but he met the girl who years later would become his wife. Back in Italy, Parmitano earned a bachelor's degree in political sciences at the University of Naples and graduated from Italy's Air Force Academy, then completed his basic training at the Euro-NATO Joint Jet Pilot Training Program at Shepherd Air Force Base in Texas. After 6 years with a fighter squadron in Italy, he was sent to France to train as a test pilot and earned a master's in experimental flight test engineering at the Superior Institute of Aeronautics and Space in Toulouse in 2009, the same year he was selected for astronaut training by the European Space Agency. Now he's making his childhood dream a reality and fulfilling a desire to push the boundaries of human knowledge.
That's who we are. That's what makes us humans. That is what makes us different from the rest of the animal kingdom. And if we don't follow our nature of being explorators, of being thinkers, then we are denying a part of ourselves that is incredibly important.
Dr. Karen Nyberg was part of a big family growing up in the tiny town of Vining, Minnesota. And from the time she was a very young girl, she knew she wanted to be an astronaut, although she doesn't know why. She learned some solitary pursuits as a little girl.
I've been sewing. My mom taught me to sew when I was probably 5 or 6 years old. I've been drawing since I was also that age. I would never sit in front of the television just sitting there watching TV. I always had a piece of paper and a pencil and was drawing or doodling or doing something.
But she took advantage of being in a small town to join more school activities than most kids in big city schools join.
I was on the basketball team, the volleyball team, the track team. I took stats for the baseball team. I was in the choir. I was in the band. I was in the drama club. I was able to participate in all of them, learn to be a team member.
She went to the University of North Dakota to study engineering and learned about a program that lets students work at NASA's Johnson Space Center in Houston. Nyberg worked as a co-op in Houston while finishing her bachelor's in mechanical engineering in Grand Forks and while starting her graduate work at the University of Texas at Austin. After she finished a master's and a doctorate in mechanical engineering in Austin, she returned to JSC, working full-time in the Crew and Thermal Systems Division for 2 years before she was picked for the astronaut program in 2000, where she met her future husband, fellow astronaut candidate Doug Hurley. Nyberg was part of the STS-124 space shuttle crew that delivered the Kibo laboratory module and Japanese robotic arm to the International Space Station in 2008 and was the first person to ever operate the shuttle robotic arm, the main station arm, and the Japanese arm. She's confident this mission will appeal to the adventure seeker in today's kids.
I think a lot of it is based just on human nature, that we are all very curious people. Human beings like challenges, and this is an ultimate challenge.
Back in Mission Control here in Houston, as we continue to watch over the shoulders of the Orbit 2 team of flight controllers led at this hour by Flight Director Judd Freeling, accompanied by spacecraft communicator Takuya Onishi of the Japan Aerospace Exploration Agency. The Robotics Systems Officer here in Mission Control, John Bellingham, reported to Freeling just a few moments ago that we are moving to within about 13 centimeters of the interface surface-to-surface interface contact between the two common berthing mechanisms, one on the HTV-4 cargo ship that was captured just under 4 hours ago by Karen Nyberg operating the station's robotic arm, and the common berthing mechanism on the Earth-facing port of the Harmony module. We still think it'll be about 10 more minutes, perhaps a few minutes less than that, before we are in a position to see the ready-to-latch indications that will be the precursor to the start of the bolting of the Japanese cargo ship into place. Once HTV-4 is bolted into place and a hard mate is confirmed through what is called second stage capture, the crew will take a break, and then later will begin the outfitting of the vestibule, the small passageway between the Harmony module and the HTV-4 hatch itself. That will involve hooking up one power cable and one data cable as an interim outfitting procedure for the remainder of the crew's workday today, before they resume that work in the wee hours on Saturday that will lead to the opening of the hatch to the HTV at about 6:20 a.m. Central Time on Saturday morning. The opening of the hatch will enable the crew to begin unloading the pressurized cargo in the racks that are located inside HTV, in which some 4,100 pounds of dry cargo and some 1,300 pounds of water are stored. There is external cargo also called unpressurized cargo, housed on what is called the exposed pallet that it resides in a slot on the side of the HTV, which will be extracted robotically by the robotics officers here in Mission Control as they will maneuver the station's robotic arm into place to extract that exposed pallet that houses two spare parts, a main bus switching unit, and a utility transfer assembly for one of the solar alpha rotary joints. Those spare parts accompanied by a suite of experiments for the Defense Department on a platform that will be affixed to the truss of the International Space Station. Late Sunday afternoon, the station's robotic arm will extract that exposed pallet, hand it off to the Japanese robotic arm at the end of the Kibo module, and that exposed pallet will be affixed to the front porch called the exposed facility on the front end of the Kibo module, where in the weeks ahead those spare parts and experiment suite will be removed from the exposed pallet and installed at various locations on the truss of the International Space Station. Now just a few centimeters away from a surface-to-surface contact between the two common berthing mechanisms, again the precursor to the ready-to-latch indications that will enable the bolting of HTV-4 to begin. The International Space Station flying from northwest to southeast over the Pacific Ocean. Flying in an orbit inclined 51.6 degrees to either side of the equator, the 6 crew members on board the stations. Work continues at this hour, wrapping up the week of work with the mating of the HTV-4 cargo ship to the Harmony module. We are beginning to see the start of the ready-to-latch indications along the interface between the two common berthing mechanisms. There are 16 bolts that will be employed to bolt HTV-4 into place, 4 gangs of 4 bolts apiece in a 2-stage fashion. The first stage capture, the bolting to be conducted by the crew from a laptop computer inside the International Space Station. The second stage capture to be ground commanded. And we now see the 4 sets of latches in the ready-to-latch position, the precursor to the start of the bolting of HTV-4 into place. Before the actual bolting commences, we'll be waiting for about a minute or two to allow any very minute relative motion between the HTV-4 and the International Space Station's Harmony module to dampen out. The 2 common berthing mechanisms precisely aligned and 4 good ready-to-latch indications on the 4 gangs of bolts and latches.
Station Houston on 2, no response required, but no exercise constraint. It's going to be a little bit extended. Sorry for your inconvenience. Station Houston on 2 for Chris for CBM.
Eastern Station, say again on 2, please.
Okay, this is for Chris. Thanks for waiting. Maneuver to RTL is complete, so you are go for first stage capture on the Node 2 NADA CBM. And in step 3, attitude control is still stable, then the thrusters are still disabled.
So with that call up from Takuya Onishi,
In work.
the spacecraft communicator here in Mission Control, Chris Cassidy, now will begin to send commands from a laptop computer inside to begin the first stage of the bolting of the HTV-4 into place.
Houston Station, starting step 4.
Copy.
This is Mission Control Houston. The mechanical systems officer here in the flight control room confirms first stage capture is complete. The second phase of the bolting of the HTV-4 into place on the Harmony node now is turned over to ground commanding.
Houston Station on 2 for robotics. Step 4 is complete. Your go for SSRMS mode to limp.
Copy. In work, and we'll get back with you once it's done.
We are nearing the end of the mating procedure here that began with the capture of the HTV-4 just over 4 hours ago when astronaut Karen Nyberg grappled the Japanese cargo ship following its 5.5-day rendezvous from its launch in Tanegashima last Saturday, U.S. time. She was operating the station's robotic arm, the Canadarm2, out of the cupola, and accompanied by Chris Cassidy, reached out and grabbed onto the grapple fixture on HTV-4 to wrap up its flawless rendezvous to the International Space Station. We're now just moments away from the hard mating, or the second stage capture as it is called, of HTV-4 to make it a permanent fixture of the station for the next 4 weeks.
Huntsville Space Station on Space to Ground 2.
This is Huntsville on 2. Go ahead, Chris.
Hi, Don. I was just checking to see if it's okay to move the lab camera from its view of the MSG.
And Chris, that's fine with you moving the camera.
Okay, copy. And we can move it back there later on if Karen has some more science to do.
We copy and understand.
Station Houston on 2 for Chris. SSRMS mode to limp is complete. So you go for second stage capture.
Okay, copy. Go for second stage capture. Picking up in step 5.
Good copy.
and a view of flight engineer Chris Cassidy as he monitors the final bolting of HTV-4 into place. We'll get the word shortly of second stage capture, which will mark the formal mating and the hard mating of the Japanese cargo ship to the Harmony module.
Houston Station on 2. Just to be thorough, making sure I'm starting in step 5.2.2. Correct?
We are with you. Thanks for checking.
That means, okay, I'm picking up in 5.2.2. You concur?
We concur.
We are moments away now from second stage capture. The second set of bolts being driven.
Houston, moving to step 5.3.2.
We concur.
Five 5.3.2 complete, move into 5.4.2.
Okay, hold on a second. We will be uplinking the template.
Okay, copy.
And Chris, you have a go.
Understand. Capturing to 70 degrees. Here we go.
Chris Cassidy working from a variety of laptop computers in tandem with the ground controllers here in Houston to complete the bolting of the HTV-4 cargo ship into place on the Harmony module.
Complete through 70 degrees, ready for step 5.5.2.
Okay, you have a go.
Copy. Complete through 40. I see the confirmation request says capture, so I'm ready for 5.6.2 if you are.
Copy, you are go.
Here in Mission Control, the Mechanical Systems Officer confirms that we have second stage capture.
As you can see, the position is at 11 degrees, and I'm checking with you in step 5.7 for CBM latch stall recovery arm steps.
Hey, Chris, that is not required, so now you can go to step 6.
Okay, copy that. I see that. If latch positions are 11 to 12, go to step 6. Roger. Thank you.
Good copy.
Second stage capture confirmed at 10:38 a.m. Central Time.
2 for HTV, not 2 vestibule pressurization. Confirm that you wanted me up 4.1.
You can perform up to and including step 4.3.
Copy, 4.3. Thank you.
Good copy.
Some cleanup procedures being called up by Luca Parmitano. HTV-4 now bolted into place on the Harmony module of the International Space Station. Again, second stage capture, the formal mating of the Japanese cargo ship to the International Space Station, completed at 10:38 a.m. Central Time as the International Space Station flew 260 miles over the South Pacific Ocean. So with the confirmation of the formal bolting of HTV-4 having been completed at 10:38 a.m. Central Time, slightly over 4 hours after HTV-4 was captured by astronaut Karen Nyberg using the station's robotic arm, HTV-4 now will reside on the Harmony module of the International Space Station for the next 4 weeks as the crew begins the process of outfitting the passageway between Harmony and the HTV-4 vehicle, and the preparatory work that will lead to the opening of the hatch to the HTV on Saturday morning and the start of the unloading of the cargo being housed inside some 3.6 tons of cargo for the Expedition 36 crew. With that, we'll wrap up our coverage for today. One programming note, Space Station Live that normally airs at this hour will resume at its regular time of 10 a.m. Central Time, 11 a.m. Eastern Time on Monday morning, August 12th, and we will be back at that time for continuous coverage of the work of the Expedition 36 crew on board the International Space Station. With that, a successful grapple and mating of HTV-4, a new Japanese cargo ship, at the International Space Station. At a mission elapsed time of 134 days into Expedition 36, this is Mission Control Houston.